Hello dear students, in today's lecture we will discuss numerical differentiation by Newton's forward interpolation formula. So by Newton's forward interpolation formula, let us take example. Here is example. Find the first and second derivatives of the ahead function tabulated at the point x equal to 1. Here is the value of x 1, 3, 5, 7, 9 and fx equal to 85.3, 74.5, 67.0, 60.5, 54.3. Now let us start the solution. See here x equal to 1 lies in the beginning of the table. Therefore, we shall use Newton's forward method because the value of x started from x equal to 1 and we have to calculate the first and second derivatives at the point x equal to 1. That's why we use Newton's forward formula. Here is the difference table of the given value. Here is the table. The value of x is 3, 5, 7, 9 and here is the value of fx. As we know by Newton's forward method, first we difference between these 2 points and we will get the value of del of fx and write down in the middle. Secondly, difference between these two and put in the middle, difference between these two and put in the middle, and same process of del square fx and del cube fx and del to the power 4 fx we have already discussed in Newton forward method. What is Newton forward difference formula? F of x0 plus uh equal to f of x0 plus u of del of fx0 plus u minus 1 divided by factorial 2 del square fx0 plus u cube minus 3u square plus 2u divided by factorial 3 del cube fx0 plus u to the power 4 minus 6u cube plus 11u square minus 6u divided by factorial 4 del to the power 4 of fx0 plus dot dot dot. This is the Newton forward difference formula. We have already discussed this method in interpolations chapter. Now, using differentiation twice with respect to u. So, differentiate. This is the Newton's forward difference formula and now we differentiate this equation with respect to u. It becomes h of f dash x0 plus uh. First we differentiate f, it becomes f dash x0 plus uh and then x0 plus uh becomes x0 is 0, uh is h. So it becomes h of f dash x0 uh and second is the first part is 0. It becomes del of fx u plus here is u squared in Newton's forward formula. So differentiation of u square is 2u minus 1 divided by 2 del square fx0 plus 3u square minus 6u plus 2 divided by 6 factorial 3 means 3 into 2 into 1. It becomes 6 del cube fx0 plus u 4u cube minus 18u square plus 20u minus 6 divided by 24 del to the power 4 of fx0. This is the first derivatives of Newton's forward formula. Again I repeat the Newton's forward difference formula. This is the Newton's forward difference formula and just we differentiate with respect to u and we will get the equation is this one f dash h of f dash x0 plus uh equal to del of fx0 plus 2u minus 1 divided by 2 plus del square fx0 plus 3u square minus 6u plus 2 divided by 6 del cube fx0 plus 4 u to the power 3 minus 18u square plus 20u minus 6 divided by 24 del to the power 4 of fx0. This is equation number 1. Here we differentiate first time with respect to u. Again we differentiate this equation with respect to u. So it becomes h of that means h square f double dash x0 plus uh in left hand side, and in right hand side it becomes del square f of x0 plus u minus 1 del cube fx0 plus 12u square minus 36u plus 22 divided by 22 divided by 24 del to the power 4 of fx0. This is equation number 2. So again I repeat the process. First we take the Newton's forward formula and we differentiate first time with respect to u. We get the equation number 1. Again we differentiate with respect to u. We get this one, h square f double dash x0 plus uh equal to del square fx0 plus u minus 1 del cube fx0 plus 12u square minus 36u plus 22 divided by 24 del to the power 4 of fx0. This is equation number 2. So what is the process? First we take the Newton's forward formula and we just differentiate first time with respect to u. We get the first derivative. Again we differentiate with respect to u. We get the second derivatives and write down the equation 1 of first derivatives, write down the equation 2 for second derivatives equation. Then after, say in problem, here h means interval of x, that means is 2, and initial value of x0, initial value of x is 1, that means x0 equal to 1, and we have to calculate the value around x equal to 1. It is given. So what is the u? U is x minus x0 divided by h. So it becomes 1 minus 1 divided by 2, that means 0. So that x0 plus uh equal to 1, because x0 equal to 1 and u of h part is 0. So it becomes x0 plus uh equal to 1. Now putting these value in equation 2 and 3, we just had a drive in previous slide equation 2 and 3. We put here the value of value of u is 0. In equation 2 and 3 we get, from equation 2 we get f dash x0 equal to dy by dx at x equal to x0 equal to 1 by h of del of fx0 minus 1 by 2 del square fx0 plus 1 by 3 del cube fx0 minus 1 by 4 del to the power 4 of fx0 plus 1 by 5 del to the power 5 of fx0 plus dot. This is equation number 3rd. So what we have done here, we have just put the value of u equal to 0 in equation 2 and we will get the equation 3. Again we put u equal to 0 in equation 3rd and we get f double dash 1 equal to d square y divided by dx square at x equal to x0 1 by h square del square fx0 minus del cube fx0 plus 11 by 12 del to the power 4 of fx0 minus 5 by 6 del to the power 5 of x0. This is equation number 4. Now from equation 3 put x equal to 1 and we get dy by dx at x equal to 1 1 by 2 of del of f1 minus 1 by 2 of del square f1 plus 1 by 3 of del cube f1 minus 1 by 4 of del to the power 4 of 1. So what is the value of h is 2, so 1 by 2, and this is del of f1 del of f1 So see in table, it is minus 10.8, and 1 by 2 del square f of 1 is 3.3, and 1 by 3 minus this is del cube of 1 is minus 2.3, and del to the power 4 of 1 is 1.6. So after simplification we get the value of minus 6.815, and from equation 4 we get 1 by 4 of del square f1 minus del cube f1 plus 11 by 12 del to the power 4 of f1, and after substituting the value of del square f1, del cube f1 and del to the power 4 f1, we get the value of the second derivatives is 1.767. So this is the process to find the differentiation of numerical solutions. So again I repeat the process. First we take the Newton's forward difference formula, and then after with respect differentiate with respect to u, again with respect to u we get the first and second derivatives. Then after in table h equal to 2, x0 equal to 1, x equal to 1 is given, so u equal to this one, u equal to x minus x0 divided by h, and after that we substitute all these value in equation 2 and equation 3, we get the first order and second derivatives, and then after from the difference table, here is del of fx0 is minus 10.8, and del square f of x0 is 3.3, and del cube fx0 is minus 2.3, and del to the power 4 of fx0 is 1.6. So substitute all these value here, and we get the first and second derivatives of the solution of the problem. So this is the process to find the numerical solution by differentiation method.